Okay, so we'd gone through some examples. You guys did these ones on the board. And then we stopped here. So we're going to look at a couple of these together. I would consider this problem as well as the next one as more like textbook type questions. You know how like our textbook ends up being a little bit more algebra heavy, like skill and algebra heavy, versus like the College Board questions end up being a little bit more conceptual. Part of that is like the College Board questions, especially like multiple choice questions, and this is probably where this topic would show up. You only have about an average of 2 minutes a question for the non-calculator active questions, and then about 3 minutes a question for the calculator active multiple choice questions. So you don't have time to go really in depth on algebra like we're about to do in this problem. Okay, so this is similar to the problems that we were looking at last class. Why don't we, first of all, let's write what g prime of 8, like what we know that would be equal to. So we're trying to find g prime of 8. G is the inverse of the function f. Referencing this rule, g prime of 8 would be 1 over f prime of g of 8. Nope, not g of x, g of 8. Last period on a Friday. Here we go. So, like we know that the function f and the function g are inverses of each other. We're trying to see what y value corresponds to x being equal to 8 for g, which on its inverse function f would mean we're trying to find the x value that corresponds to y being equal to 8. So in order to find this x value, which would then give us what g of 8 is, we can think about setting f of x equal to 8. Okay, and then now we have polynomial equation to solve. If we get 0 on one side of the equation, our goal is to factor. It's a cubic, so we can't just use guess and check. We can't use quadratic formula. So we have to use like the more complicated like form of guess and check here. Do we remember what we'd have to do for higher degree polynomials like this to try and factor? Yeah, we'd use the rational root theorem, meaning we'd list all the possible rational roots to this equation, or all the possible rational zeros. Hopefully this is like ringing bells for you. I don't think it would be worth your time to go back and like go super in depth on this if it isn't. I've never seen this level of having for factoring a polynomial come up from College Board at least. But you did do this in pre-calc honors or in pre-calculus, wherever you came from. So listing all the possible rational zeros, right, we would have plus or minus, I don't know why I put x equals. We'd have plus or minus. Factors of 7 would be 1 and 7. Factors of 2 would be 1 and 2. So that means our possible rational zeros would be plus or minus 1, plus or minus 1/2, plus or minus 7, plus or minus 7/2. And you guys saw last year, whenever you were trying to factor, what'd you do to test the zeros last year?
Synthetic division.
Synthetic division, right? To see if you get a remainder of 0. It's usually a good idea to start with 1. So why don't we do 1? So if we're using synthetic division to test 1 to see if 1 is a 0, you put the coefficients of the 2x cubed. We need a placeholder for the x squared term. 5, -7, bring the 2 down. 2 times 1 is 2. okay? So to rewrite this equation, we would have 0 equals, right? We got a remainder of 0, so that means x minus 1 is a factor. 1 is a 0 of the polynomial times 2x squared plus 2x plus 7. And that's a quadratic. If we thought about trying to factor that, you're like, oh, doesn't work. If you thought about trying to use quadratic formula, the discriminant, b squared minus 4ac, ends up being negative here. Like if you were like x equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? Like the discriminant ends up being less than 0. So therefore, we can't factor that any further over the real numbers. The only real solution to this equation will be x equals to 1, which is good. That makes sense here. That means that g of 8 is equal to 1, right? Well, actually, first we found that like f would have the point 1 comma 8, which means 8 comma 1 is on g. So we know that g of 8 is equal to 1, which means we need 1 over f prime of 1. Since we have f, we can go ahead and find f prime. And then pop 1 in there. And we get 11. So 1 over 11.
Mr. Smith, if there have been other factors, would there be multiple answers instead of just to like plug it into f prime multiple times and get multiple answers?
That's a good question. If you had multiple solutions, would f be 1 to 1?
No. Oh, so it would be no solution?
Be no solutions. But that's actually a good question leading us into the next question, which is what I would consider more of a textbook question, because I do feel like it's kind of poorly worded. Yeah. Yeah.
Okay.
Thanks for checking.
Yeah.
I was on it for once, although I missed the whole first part, but that's okay, right? They can't see it anyway, so, you know, it's fine. It's fine. Okay, so we need to find g prime of 10. Here's the issue. What's the graph of f look like? It's a parabola. Would that pass the horizontal line test? No, siree. Let me see. Right? Oh, I already did the work for it. Why does it do this? Why does it do that? Every single time I try and use Desmos, it does that.
It doesn't do that on the website.
It might be because I'm projecting. Okay, anyways, it's a parabola. And so over its implicit domain of all real numbers, not 1 to 1, right? Meaning there's not an inverse. But if we thought about restricting the domain, one way you could restrict the domain to make the function 1 to 1 is by like cutting the parabola in half. So like if we wanted to find the axis of symmetry here using, so like the AOS, think back to algebra 1, would be negative b over 2a. So negative b over 2a, we would get 1/6, okay? Meaning f is 1 to 1 from negative infinity to 1/6. Like we could have f defined for x less than or equal to 1/6, or we could have f defined for x greater than or equal to 1/6. Okay, so either of those graphs would be 1-to-1. Okay, so we're going to kind of hold that thought. Now, if we were trying to find g prime of 10, like, okay, using that formula, 1/f prime of g of 10. And here's where we're going to end up with two different values for g of 10, okay? So, like, if we're thinking about f and g, right? Like, we want to find g of 10, which will correspond to whatever that value is, comma 10 on the graph of f. So essentially we want to think about setting f equal to 10. If we get 0 on one side of the equation, this is factorable. So, what is that, -2 plus 5 here? So we get two solutions to this equation. So x equals to -5/3 and x equals to +2. So like x equals to -5/3 lies on the interval whenever x is less than or equal to 1/6. So we could say, like, for f, when x is less than or equal to 1/6, when we find g prime of 10, it would be 1/f prime of -5/3. Whereas when we go to find g prime of 10, for if the function we're dealing with was x greater than or equal to 1/6, we would have g prime of 10 would equal to 1/f prime of 2. Again, I think the wording's kind of funky here, like the fact that f isn't actually 1-to-1 over its implicit domain and no domain is explicitly stated. But this is what the textbook is like intending you to do, be like to recognize that and deal with it. Yeah.
And then if something like this showed up on the test, would that like be the notation for it? I guess like the.
I don't think this would show up from, you're talking about from College Board?
And for your test.
I don't like it. I probably wouldn't ask a question like this,
Okay.
to be fair.
And this wouldn't show up on the college.
I don't think so. But you've seen it if it did, right? It's just showing that there ends up being two different values for g prime of 10 depending on the domain that f was restricted on. So we still need f prime. So 6x minus 1, so we could find f prime of -5/3. Ooh, where's it going? So 6 times, was that -11? So we'd get -1/11 versus f prime of 2 would be +11. So 1/11. So we get the two different values for g prime of 10, again, depending on which domain you're thinking of f being defined on.
If it's a symmetrical function, will it always end up being like number and then like negative or positive saves then?
Well, if it's a symmetrical function, like if it's an even function, it's not 1-to-1. But you're saying like if you considered one side versus the other. Yeah, I think that would, well, no, not necessarily. So let's think about that. Like think about for x squared. Like if we thought about x squared. Right, so this side or this side. So it would either be this or this. I don't know. I'd have to think about that. Maybe that would work. Wait, no, because it would be positive. Maybe it would work. I don't know. I don't know.
Should probably find the jade circle.
But
Interesting.
right, technically, if it's symmetrical about some sort of axis, then it's not 1-to-1. So then it doesn't really make sense to talk about an inverse. But that's why the wording of this one bothers me a bit. Yeah. I guess so. Okay. I have been yapping a bunch. Let's put you guys into groups to do this one. Why don't we go why don't we go 3 in the back over here? You guys can erase what's there. Okay. We'll go you 3 will go over here, and then you 2 and Dennis will be up here. For this last one, you're going to erase whatever's at your board.
So the original formula is
Why are you so fast and aggressive even when you are talking?
Times g of 1/2.
G5
Is that 1/2 equals
so
cosine g?
G5 of 1/2 is G of 1 and F5.
Well, because that's x, right?
G of what inverse is that? So we have to find this first. So we find the inverse of this first.
I think we could just find the number that g.
1/2
I'm not really
blank.
Oh, like.
Blank.
Okay.
So okay, so now we plug in 1/2. So why are you doing this? Each of you do the 1/2.
Okay, I'll do like okay.
1/2 is equal to so then 2 times sine of
Now, and most people wouldn't know how to do this.
2 times
You're one of them.
1/2 equals cosine g, right?
When you make this cosine squared minus sine squared, right?
Cosine.
And then-
Oh, because it's the y.
Actually,
It's
it's
the
like-
same thing as like
Cosine x plus x. So cosine a plus b is.
No, you
Okay, and then you
You're over here, Dennis. They just started.
It's so nice and warm outside.
I know, it is nice out.
Okay, I remember Sven's teaching us.
Wait, hang on, I don't think that's right.
No, hang on. Shut up.
cosine of something.
Okay, guess not.
Cosine is
So what do we do from here?
Remember it's like
well,
it's like let 2
Wait, no.
I know. 1 minus.
Oh, yeah.
Pi over 3.
Wait, just erase whatever.
I don't know. I'm at the wrong.
Yeah, no, I think you're right.
So that means 2x.
Is there a range? Yeah, it's to pi 2.
Could have used
Plus
this.
pi over 3. So the range is
Well,
shown
that's
here.
good.
Oh, how about the
We just tried different ideas.
x equals pi over 6.
Right.
So now the range. Okay.
Okay, now it's fine.
Now,
Now you just use it as
Oh, no, wait.
yeah, to define
I
this.
moved the 1 to the other side.
You do not move the 1 anywhere.
You
No,
could also
what?
only have
One
considered
minus 1
Oh,
is negative
I
1
was
half.
looking
So
at,
divide both
like
of
on
them.
your plan
Divide
out,
out the
looking at
1
what
to
the interval was there.
Hmm.
So if x is between 0 and 5 or 2,
Is
right?
that-
That's only one quadrant, right? It's only gonna be, but you could also think about it, like a larger interval is that if you multiply each part here by 2, you're like, oh, 2x has to be on the interval from 0 to pi. right? So on the interval from 0 to pi, thinking Q1, Q2, there's only one place that
Okay,
cosine
I didn't know we could do that.
positive.
I don't think we can do that.
No, we
So
can't.
you.
That can be helpful when you're actually
I don't think you can do that.
Okay, so now the next step. So we have to run inverse of this, right? Or what should it be?
X should be,
Wait, isn't this the y value for?
but then you X would be
Yeah.
higher.
But I don't know how this works actually. I need to check.
Well, I think this is used to
Oh, you can.
Yeah, that's what I meant. This is the y value, the x value for f of x, and it's opposites.
yes, and now we have.
No, it's right here.
Sin 2 sin
Yay! Okay, cool. So now f prime of pi is
Sine
This
of
is like
sine
double
of
test.
sine
You
of
get it?
3.
You get the singles position?
You're trying to
So fast, am I?
Oh, you're
It's okay.
So
Oh, it's not at all fast.
Oh yeah,
This
yeah,
is-
yeah.
How do you come up with this one?
what are we doing?
Five
Is
percent.
negative
Thank you.
sine minus.
You get this.
Thank you.
So sine of pi over 3 is.
Lucas, what else is it? Lucas, one. Lucas, one. You get
No,
it.
I think, yeah, I think so. Negative 2.
Wait, is this? No, I think it's 1/2 actually. I disagree. Because the thing is, 1/2 is greater than. the
No,
square.
you're definitely wrong. I'm definitely right.
Wait, no,
It's
it's
cosine.
wait, no, you're right, you're right, because this is greater than 1. No, this is totally right.
Yeah, it's the
Yeah.
Yeah.
No, yep, no, I'm wrong.
So there's a nice coffee there. Anyways, so the next step is 1 over this, right?
Yes.
So it's going to be equals irrational. Oh my goodness, I can't believe you actually
Is this
did
right?
this on your own.
So take a picture. Make sure you get a picture. All right, once you guys finish and take a picture of your
Yeah.
work, go ahead and download the 5.4 notes. Your homework is only going to be on 5.3 and to study for your 5.1 through 5.3 quiz. That's next class.
Miss Dorsa, please don't tell me we're gonna take the quiz today.
We're not. We're gonna do 5.4
Well,
right
like,
now.
No, because we did like 5.1, 5.2, 5.3, 5.4, 5.5.
Does it feel like we're like we're like going real
and
fast?
So we're literally
Rolling
gonna
through.
take
They're
the
just
test
short
right now,
questions.
right after we do 5.4.
It's like different than chapter 4, right? Where we're like, this is 4.2 part 3. Okay.
It's like, right now,
If we
we're
finish
gonna
the notes
No,
really
no,
fast,
no.
now we could take
No,
the
hold on.
quiz now.
Would you rather?
I don't even have the quiz written.
Or buy later.
Literally, what are you talking
What
about?
does that mean? Okay now.
Literally.
Oh, Denden's
No, buy now.
No,
No, would you rather? Wait, no. Would you rather buy now or
We
pay
erased
later?
the board.
Yeah. Fine.
That would be nice.
Your student work.
So we forgot the board.
What does that mean?
No, would you rather buy now or pay later?
Yeah.
Then it's
Okay, like, Apple Cash.
Okay.
Totally not. Anybody associated with loaning at all, because it's clearly we're paying.
So next up, actually I can stop recording because I have 5.4.